This video will cover some introductory information on Amazon S3, or Amazon Simple Storage Service. S3 is storage for the internet. It's designed to make web-scale computing easier for developers. Amazon S3 has a simple web services interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. It gives any developer access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. One of the greatest advantages to S3 is that it's intentionally built with a minimal feature set that focuses on simplicity and robustness. It'll allow you to create and name a storage bucket that stores data. Buckets are the fundamental container in Amazon S3 for data storage. It'll also allow you to store an infinite amount of data in a bucket. You're allowed to upload as many objects as you like into an Amazon S3 bucket. Each object can contain up to 5 terabytes of data. Each object is stored and retrieved using a unique developer-assigned key. You're also able to control your permissions for S3 by granting or denying access to others who want to upload or download data into your Amazon S3 bucket. You're able to grant upload and download permissions to 3 types of users. Authentication mechanisms can help keep data secure from unauthorized access. It's also designed to be very easy to use because S3 uses standards-based REST and SOAP interfaces designed to work with any internet development toolkit. Now that we've talked about a little bit about what S3 is and some of the advantages it offers, let's talk about some of the key concepts for S3, and the first and most fundamental is the bucket. A bucket is a container for objects stored in S3. Every object is contained in a bucket. Buckets serve several purposes. They organize the Amazon S3 namespace at the highest level. They identify the account responsible for storage and data transfer charges, and they play a role in access control. And finally, they serve as the unit of aggregation for usage reporting. Next are objects, which are the entities stored in Amazon S3 buckets. Objects consist of object data and metadata. The data portion is opaque to S3. The metadata is a set of name-value pairs that describe the object. These include some default metadata, such as the date last modified, and standard HTTP metadata, such as content type. You can also specify custom metadata at the time the object is stored. An object is uniquely identified within a bucket by a key and a version ID. And when we start to dig into S3 on the console, you'll get a much better idea of what I'm talking about. Next is a key, which is the unique identifier for an object within a bucket. Every object in a bucket has exactly one key. Because the combination of a bucket, key, and version ID uniquely identify each object, S3 can be thought of as a basic data map between bucket and key and version and the object itself. Every object in S3 can be uniquely addressed through the combination of the web service endpoint, bucket name, key, and optionally a version. And finally, you can choose the geographical region where S3 will store the buckets you create. You might choose a region to optimize latency, minimize costs, or address regulatory requirements. Objects stored in a region never leave the region unless you explicitly transfer them to another region. And now that we've covered some of the key components of S3, let's talk about S3's data consistency model, and that includes read-after-write consistency and eventual consistency. S3 provides read-after-write consistency for puts of new objects in your S3 bucket in all regions with one exception. The exception is that if you make a head or get request to the key name before creating the object, S3 provides eventual consistency for read-after-write. For overwrite puts and deletes in all regions, S3 offers eventual consistency. So, to quickly reiterate here, for puts of brand new objects in a bucket, S3 will provide read-after-write consistency. But for overwrite puts or deletes of objects in any region, S3 will provide eventual consistency. S3 achieves high availability by replicating data across multiple servers within Amazon's data centers. If a put request is successful, your data is safely stored. However, information about the changes must replicate across Amazon S3, which can take some time, and so you might observe some of the following behaviors. One behavior is if a process replaces an existing object and then immediately attempts to read it. Until the change is fully propagated, S3 might return the prior data. Another scenario is if a process deletes an existing object and then immediately attempts to read it. Until the deletion is fully propagated with eventual consistency, S3 might once again return that deleted data. And that about covers it for S3 Basics and S3 Data Consistency. So if all of that makes sense, then feel free to move on.